Uh, Basically, we are discussing the topic about classful IP addressing and subnet, as well as some problems with the solutions. So, before discussing classful addressing, we want to say what is IP address. IP address is basically the location identity of a particular computing device. That computing device may be a computer, maybe a mobile phone, maybe a printer, or maybe any other small or big uh, device which has a network connectivity. The network may be internet or maybe a LAN network that we generally see in our institute's lab. So network connectivity, when there is, the location identity of that device is very important. IP address actually identify that particular computing device. However, this IP address has two parts. One is the location identity of the particular network. That is, for example, in our lab, the particular network is the LAN network of that particular lab room. And there are many 30 to 40 to 50 computers are there. Among them, every computer has some identity. So this network identity and this computer identity, we generally say as host identity, are very important. So there are two parts in this IP addressing architecture. One is the network identity, another one is host identity. We can give an analogy. For example, a person is staying in a big building. In that building, many persons are staying. So first of all, we have to identify the location of that particular building through the PIN number, post office, the city, state, district. Then we have to identify that particular person within that building. So there are also two parts. So today in this small lecture, we are discussing about IPv4 address. We are considering IPv4 address only. So IPv4 we know that is 32 binary bits size, and the addressing architecture of IPv4 address include two parts among these 32 bits. First few bits are for the network identity, or we can say net ID. The second part or the remaining bits identify a particular host, and we can say it is an host ID. Okay, so classful, that is a particular kind of addressing where we have decided already the size of the network. Okay, and the network size may be of many sizes. It may be a very small network with only 255 number of computers, or a medium sized network with number of computers 2 to the power 16 in this range, or a very large network of size 2 to the power 24. But if the network has less number of computers than the actual capacity, or something in between these numbers that I have told, that is a classless addressing that we will discuss in the next lecture. But in this lecture, we will concentrate only on classful addressing, where number of hosts is fixed for a particular class. So in this slide, we are showing different classes of IP addresses. There are basically 5 classes, and we name them as A, B, C, D, E. Class A is the has the highest number of hosts in it, and that is 2 to the power 24 number of hosts. And that's why here, if we see, the net ID is only 8 bits. That means only 255 kind of networks are possible, and many like 2 to the power 24 number of hosts are possible within that network. Generally, mobile operator like current operators, which are provides the SIM card to a mobile phone, they purchase this kind of addresses from the internet service provider. Then the medium size network, that is class B, or 2 to the power 16 number of networks are possible, and 2 to the power 16 number of hosts are possible. Generally, a large organization like a software company purchase this kind of class network. They may have many branches, and then they make a subnet, and then they provide each branch a particular network address. Class C, a very small network, a small organization where number of hosts are very limited, only 256 number of hosts are possible, because 2 to the power 8 equals to 256. And this class D and class E, class D is for multicast address, because sometimes we have to send some message to many computers. So individually we cannot say to every computer separately. We use multicast address to send to every computer within a subnetwork or within a network or within the internet also. At that time, the special address, that is multicast address, are used. And remaining addresses, that is after this, some addresses are used that is reserved for future use. Now we have to identify class A, class B, class C, class D, class E address by its bit pattern. Okay. So first we go to class A address. We always see the leftmost bit. If the leftmost bit starts with a 0, we will not check any other bits, and we will certainly say that number of bits in this class to determine the network is 8, and it is a class A address. Now you can ask a question: if the leftmost bit is 1, obviously class B must start with 1. Then we have to see whether any other class belongs after class B. Yes, class C is there. So obviously the second bit we have to select as 0. If there is no class remaining, so we can just say 1, and no need to say the remaining, that is the next second bit, as 0. Similarly, class C, obviously if it is 1 0, the identity of the first 2 bits have been already lost by 1 0. So the remaining, that is the second bit, we can change now, and it will be 1 1. Okay. So we have to identify now, after class C, is there any other class? Okay, class D is there. So the next third bit will be 0 here for class C, and that bit will be 1 for class D. Again, we have to identify class E is there. So the fourth bit from the left is 0, and the fourth bit is 1 for class E. So any address, if it starts with 0, it will be class A. And if it starts with this bit pattern, we can easily determine which class this address belongs. And whenever the internet service provider assigns or allocates address to any institute or organization, they follow this structure, and it will be very easy to allocate. Now we can see the size of each classes. Now we see as class A address has 2 to the power 24 number of hosts, 50% of addresses, 50% of total entire addresses belongs to class A. Because the first bit is 0, we cannot change it. So the remaining bits we can change, and that is total number of bits that we can change is 32 minus the first bit, that is 1, so 31 bits. So the total address possible is 2 to the power 31, and whatever the number, it is the 50% of 2 to the power 32, that is the total number of addresses. Similarly, for class B, if we go to the previous slide, for class B, these 2 bits are set, and remaining 30 bits are we can change anyway. So almost 25% of the entire addresses are belongs to class B. Similarly for class C, because 32 minus 3 bits are specified for class C, and 4 bits for class D and E. So 2 to the power 28 and 2 to the power 28. So this is the actual size, how many addresses are possible in different classes. Now we have to determine the starting and ending address of each class. So we have presented here, it is in a table. In this table, multiple columns are there for different class. So the leading bit, that is which bit is fixed actually. So for class A, the leading bit is 0, the leftmost bit, and number of net ID bit obviously 8, host ID obviously 24, and number of networks possible. So the actually how many networks are possible. First bit, if it is fixed and it is 0, then the remaining bits among the net ID, that is 8 minus 1 equals to 7, are for networks. And total number of networks possible is 2 to the power that number 7 equals to 128. And host ID, we know hosts for class A is 24 bits long. And so number of hosts possible is 2 to the power 24. And the starting address, obviously if the leftmost bit is 0 and we keep all the remaining bits as 0, the address will be 0, 0, 0 dot 0 dot 0. And the end address, that is all will be 1, but the leftmost bit, as it is fixed, it will be 0. So if we make all 1, the first octet, that is first 8 bits, will be 127. Because if the leftmost bit is 1, it means it is 128, and if all the bits are 1, it is 255. So 255 minus 128 is 127. So the end address will be this one. Similarly, we can check class B. Obviously, the leading bit is 10. The net ID is 16. Host ID is 16. Number of networks possible. As 2 bits are fixed, the number of bits for networks are 2 to the power 16 minus 2. That is 2 to the power 14. And for how many bits for hosts? 2 to the power 16. The first address will be all zeros except the first 2 bits. And the first 2 bits are 10. So it starts with 128. Similar argument we can do for determine n address, and for all we can say the same thing. Now here For class D and E, the net ID bits and host ID bits are not defined, and the starting address and ending address as per the logic for class A, B, and C. Okay, so here we are discussing some example problem that may arise in this classful addressing of IPv4. In this first question, we are given two binary representation of IPv4 addresses A and B, and we have to determine the decimal equivalent dotted decimal notation using dotted decimal notation. So what we have to do, we just have to convert the typical binary to decimal conversion for every octet. And for this octet, first this bit is 1 means it is 128, as it is there are total 8 number of bits. It starts with 0, 0 to 7, and it is 2 to the power 7, and it is 2 to the power 0. Both will be summed, and the result will be 129. Similarly, it will be 11, and it will be 11, and it will be 239, as it is the 2 to the power 4 will be minus from all the ones, that is 255. So 255 minus 16 equals to 239. Similarly, we can do this one was the same logic. In the second constant, the reverse thing we have to do, that is the dotted decimal notations are there. We need to convert it into binary. We use a typical decimal to binary conversion process, and we need to remember that every octet is 8 bits long. Even if it is a very small number, for example 7 here, we have to append all the zeros before the number we get, and total number of bits for every octet will be 8 always. Then the next question, find the class of each address. It is a logical kind of comprehensive question. So if it is binary representation is given for like A and B, we can easily say, because if I say the first bit is leftmost bit is 1, a 0, that means it is in class A address. If the leftmost bit is 1, and then we have to check the second bit. If the second bit is 0, it is class B, but it is 1. So we have to determine, we need to again check third bit from the left. If it is 0, that means it is class C. If it is 1, although in the question it is not, and we have to check the fourth one. Okay, so this way we can determine. The same logic we can apply if it is represented as dotted decimal also. Just we have to convert the first octet into binary. For example, 14, 23, and whatever the remaining one, we have to convert 14 into binary. And if we see that all the leftmost bit will be 0, leftmost bit is 0 here, if I convert by 14 into binary. So obviously it is in class A. Now 252, it is very interesting because 252 is equals to 255 minus 3. So the last right from the right, the last two bits will be 0, and all the remaining bits will be 1. As the first four bits are 1, we can easily say that belongs to class E. Okay, so that's it. And here we have summarized number of blocks and block size in classful IPv4 addressing. And see the slide. Now, main conclusion of classful addressing is that it is a huge wastage of IPv4 address, because maybe in my organization or in my institute, all the IP addresses are not used, but suppose I need only 7 IP addresses. But the minimum number of IP addresses the service provider sells can sell is 255 or 256 number of IP addresses. So if we purchase that, all the remaining 248 bit address is just washed. Okay. So similarly, if my requirement is only 300 IP addresses, I have to purchase a IP address of class B with host size up to 2 to the power 16, and the remaining IP addresses after 300 will be posted there. So this classful addressing is not an efficient procedure; it is obsolete, and we have to switch back to classless addressing that is much more efficient as per the requirement of the client of the customer. The IP before address can be provided by the service provider. Okay, so that's it. Thank you.